Okay, we're going to go ahead and get started with our algebra remediation. The biggest thing you need to have open on your computer is you need to make sure you are watching this video as well as opening up the calculator that is available to you on Edmodo. So take a minute, pause the video, go ahead and open up the calculator on Edmodo that is available during the EOC. The calculator is found if you click on this link. It'll pop up. This is the calculator you will be allowed to use when you take the EOC. We're going to use that calculator today as we go through the problems. The problems I'm using for you today came from the Ohio Department of Education's website, and I'm just going to show you how to do the problems so that you can prepare for the EOC next week. Question number 1. Complete the first table so that f of x is a function, and complete the second table so that g of x is not a function. What you need to know is that a function, by definition, means that every single x value has only one y value. So if I look at the table of f of x on the left side, I know that -1 is going to go to, I can make any number that I want, so we'll say 7. The only thing that would make f of x not a function is if I would make this a -1. Because now -1 goes to 7 and -8. So that would be the only incorrect answer that I could make. Or if I make this 6. If I make that 6, this would have to be -8 as well. This is now a function. Every x value has only one y value. Another example would be 5 and 8. Every x value has only one y value. So if you want to look at g of x, how do I make this not a function? I make so that one of these two x values, -1 or 6, has two separate y values. So if I make -1, again, I have -1 goes to 7 and -1 goes to 8. It is now not a function. So I can make this whatever I want. This is not a function. Every x value has only one y value. Now let's go to the next one. Number 2. Juan wants to rent a house. He gathers data on many similar houses. The distance from the center of the city, x, so my x value stands for the distance from the center of the city, and the monthly rent for each house, y, are shown in the scatter plot. Juan models the data with a linear equation. So if you were to model this data using a linear equation, that's exactly what we just talked about when we're talking about regression. The path of regression is the linear equation. What would the number 1,275 represent in your equation? Would it represent the slope or the y-intercept? We know that a linear equation is y equals mx plus b. So I have to know two things. I have to know the slope or I have to know the y-intercept. Would 1,275 represent the slope, meaning the rate of change? Is it changing $1,275 per mile? No, because it's decreasing. So the slope would have to be negative. Okay, if I were to draw a line in this, it would be a negative line. So I can't have the slope be 1,275. Therefore, it has to be your y-intercept. Well, what did we talk about this? What does y-intercept represent? It represents the starting value. Could the starting value be 1,275, which would be way here? Oh, that's too far. 1,275. Could that be the y-intercept? Absolutely. So we need to know the starting estimated rent would be start at the center of the city at 1,275. Which answer represents that? Estimated rent for the house in the center of the city. Answer A. Question number 3. Function f of x undergoes a single transformation to create function g of x. The graphs of both f of x and g of x are shown. Create g of x in terms of f of x to show the relationship. So If I look at these two equations, f of x is the bottom left one, g of x is the top blue one. What changed to go from the black one to the blue one? It went up 1, 2, 3 units. So we added 3 steps for every single point. So basically we just took f of x and we added 3. If we were to go right or left, we would put it inside the parentheses. If we go up or down, we're going to add or subtract. A scientist is studying wildlife. She estimates the population of bats in her state to be 270,000. She predicts the population to grow to at an average annual rate of 2.9%. Using the scientist's prediction, create an equation that models the population of bats y after x years. In this question, they expect you to know what the exponential growth equation is. Exponential growth equation is p times 1 plus r to the x power. P is your principal or your starting amount, r is your rate or your percent, and to the x is your time, or a lot of times they would put t in my case. Okay, so what amount, how many bats am I starting with? 270,000. So my P is going to be 270,000. My R is my percent, always, and that was 2.9%. I just have to write the equation. I don't actually have to find the answer. I just have to write the equation. So I'm going to plug in P and R and simplify. I'm going to get 207,000 times 1 plus 2.9% written as a decimal. So I'm going to be, I'm going to move the decimal to the left 2 times. I'm going to get 0.029. So I'm taking 1 plus 0.029 to the t power. Actually, in this case, we want to use x because they told us. If you look here, they want it to be after x years and not t time years. I'm going to go ahead and change that. And this would be the final answer, the number of bats. Now, the only thing you can simplify in this equation is what's inside the parentheses. You cannot distribute the x inside these parentheses because of the plus sign. So my final answer would be 270,000, 1.029 to the x power. The test would accept either answer and give you full credit for this answer and this answer. But the only thing you would have to remember is this is the rate of change. And this problem comes up again in the future. So make sure, go over this and know that P is the starting point, R is the rate or the percent, and T is time. Question 5. Question 5, we're going to learn how to use your calculator on your screen. How to use the calculator that is given to you for this test. The function is shown, f of x equals x squared plus 2x minus 3. Use the add point tool to show the x-intercepts in max or min of the function. Now, we know what x-intercepts are, so we want to know when this has x-intercepts, meaning when does it cross the x-axis. Well, if we could see it on a graph, we could go ahead and plot it onto the answer key. So go ahead and get your calculator. And I'm going to go ahead and graph this. Click on Graphing. And over here, I'm going to type in my equation. There it is. X squared plus 2x minus 3. Click on here. Your variable is over here. X variable. The squared is the little caret sign down here. X caret 2. That means squared. plus 2x minus 3. So I just put my function into the calculator, and now I want to see the graph so that I can put the same graph points onto my answer key. So go over here and click on graph. Now, one thing you want to make sure you use is right now it's just showing me the picture of the graph. What's really, really nice is if you click up here where it says trace, it allows you to trace the graph so that you can get the x-intercepts. So I'm going to trace this graph until I get to x-intercept, meaning y has to be 0. What is my point right there where the line hits the x? It's 1, 0, and I got that from the top up here. 1, 0. So my first point is going to be 1, 0. My next point I'm going to trace to the other side of the graph. Oops. Accidentally clicked scroll. Go ahead and click trace again. I'm going to go to the other side. All right. I have y equal to 0 again up here where my points are, and my other one is negative 3, 0. The other thing they want you to find is the max or minimum point. Looking at this graph, is there a minimum point or is there a maximum point? There is a minimum point, and it's way down here. Okay, so what I want to do is I'm going to use my trace tool, and I'm going to get down there to the most minimum point. And that's how I solve this graph. The quickest way to do it in the least amount of time. I'm going to watch my points up there in the top. There it got smaller. The most minimum point, and it looks like the farthest it gets down is negative 4. So my point is negative 1, negative 4. So my minimum is negative 1, negative 4. I got that from up here. Now it's asking me to put those 3 points onto my answer key. So what I'm going to do is I'm going to go back over my answer key, and I'm going to plot those 3 things. I'm going to put 1, 0, which would go right there, negative 3, 0, which would be right here, and the minimum point of negative 1, negative 4. And that will give you full credit. Not difficult, you just have to be able to interpret the question and graph it on that graphing calculator and know that you can trace that graph and get any point that you want. And the biggest thing you need to know is right here, in order to add those points, you have to click on the add point button. So I click that and punch those in, and it will give me the solution. That will give you full credit. Let's go to another one. Fred solved the equation 8 times the quantity 3x minus 7 equals negative 6 times the quantity x plus 7 plus 4, as shown. We have to find, Fred made an error between step 1 and 2. A, explain the error that Fred made. So let's look between step 1 and 2. Well, what did Fred do here? He distributed the 8 and got 24x minus 56, which is correct. Then he distributed negative 6 and got negative 6x minus 42, and then there's still the plus 4 at the end. He got rid of the parentheses. Then here's where Fred made a mistake. He took 24x minus 56. He still has that, but he has equals 6x plus 46. What did Fred do wrong? Fred took negative 42 plus 4 and added them incorrectly. What is negative 42 plus 4? Negative 38. So it tells me explain the error that Fred made. Make sure you are very precise in what you want to put. This is an open response question. It's not a difficult question. It's open response. You want to say, Fred made an addition error in step 2. negative 42 plus 4 is not, what did Fred put? 46. And then it says, part B, what is the solution to the original equation? Well, now we explained the error. Now we have to go back up and we have to resolve that equation. So we're going to start here at step 1, and we're going to have 24x minus 56 equals negative 6x minus 42 plus 4. Now when we add this, we're going to get negative 38, which is going to be correct. I'm going to get my x's on the same side, so I'm going to add 6x to both sides. I have 30x minus 56 equals negative 38. Now I want to add 56 to both sides. So I have 30x equals, that's cancels, negative 38 plus 56 is positive 18. Divide by 30. It does not divide evenly, but we can reduce the fraction. 18 over 30, divide the top by 2, gives me 9. Divide the bottom by 2, gives me 15. 9/15. However, we can keep dividing that. We can divide both of those by 3. So let's reduce it again. It would be 3/5. Divide the top by 3. 9 divided by 3 is 3. 15 divided by 3 is 5. Therefore, we would go down to our answer. Spot to type in our answer. We say the solution to the original equation is 3 divided by 5. Now they do not give you a spot to enter in a fraction, so make sure when you type in, just use the /. It's down there with the question mark on your keyboard. This would be a full credit answer. It's not a difficult problem. The hardest part is just typing out what you think. Go through step by step, and you just got a response question. You got full credit. Okay, question 7. A system of inequalities is shown. Part A. Use the add arrow tool to graph the boundary lines of the system and place a star on the coordinate plane to show one solution to the system. Well, these are inequalities. Basically, they're lines, and we've done these before. Okay, so if you're not sure how to graph them, remember, you can always use your calculator and it will graph it for you. So if I go over here to my calculator and I'm like, I don't remember how to graph this, I'm going to go ahead and just type this in. There we go. Okay, so I'm going to type in 5. So I want to know what that one looks like, and then I'm going to type in 2/3 x plus 3. Make sure, since this calculator does not have a fraction button, you're going to have to use your parentheses up here. So I'm going to put in 2 divided by 3 for 2/3. And then I'm going to put in x, my x variable, plus 3. To see the graph. Now, if you want to, what you can do is you can also change these to match this. Now, we know it's going to be a solid line because they're both y is greater than or equal to, but they don't have that. So if you just put greater than, you just know how you can make it a solid line. And this one's going to be less than. And what it'll do is it'll do the work for you. Click over at the graph. Now, we can't see it all, so we have to probably zoom out a little bit. So click the zoom out. It's going to zoom out for you. It's going to give you the answer. Now, you have to understand what the question is asking them. Use the add arrow tool to graph the boundary lines of the system. So what we're going to do, we have the answer on our calculator. We just have to transfer that onto our graph. So let's look at this. X is greater than or equal to 5 is the horizontal line at, I'm sorry, y is greater than or equal to 5 is the horizontal line at y equals 5. So I'm just going to go ahead and graph that. I'm going to leave my calculator so I can see both of them. I'm going to come to 5. I'm going to graph my line at 5. Now, here's what you would use. Okay? You would add points and add arrows and all that stuff. I don't have that available. You would do that, and you would have this, and it would be a solid line. Now, remember, if you're not sure how to graph this, remember, 2/3 is your slope, and 3 is your y-intercept. So we're going to start at 3, and we're going to go up 2/3. You can kind of make sure that it matches what they have on your calculator. Or down 2 back 3. And then you're just going to connect these points. Now, this one is less than, so it's going to be below. How do I know where to put this star? Where to drag this star like it asked me to in part B? Well, if you're greater than 5, that means this part right up here is going to be highlighted. Up here. If we're less than 2/3 x plus 3, that means if we're going to be on the bottom side. So that would be right here on the bottom of this graph. Where do these two colors intersect? Where do they intersect? Where do I place my star so that it's correct? Right in this area right here. Okay, this is the area where they intersect. So I want you to grab your star. See if I can find myself a star. And you're going to put your star in anywhere in that area. That would be a full solution. Now you don't have to shade. I just want to show you the thinking. And you can see that over here. You can see that if you were to put this in your graph, the only thing you have to do is graph the two lines and then put a star right here. Put your star in that area right there. Make sure you could hit a line, but just try to keep it in here. Okay, let's move on to the next problem. That would be another full answer. Question 8. A system of equations is shown. It says, what are the solutions of the system of equations? Now, the easiest way to solve this is to graph both of the lines and find out where they hit each other. If you know how to use a graphing calculator, it'll answer over half of these problems for you. You just got to think about it. Solutions is going to be where they hit. At what point do these two lines hit? Actually, one of them is a line, the other one's going to be a curve. But it doesn't matter. You can graph it. You can find where they hit. So let's go over here to our graphing calculator. Go back over to our input, and we're going to put y equals y equals 3x times 2. And I'm also going to put in y equals and then x squared. Now that I have my graph, I'm going to go, or my equations entered, I want to go over to my graph. Now I can see that they intersect, but I can't tell where. So what I want you to do is zoom. Zoom it and move it so that you can see it. Zoom it and move it. So that you can see what's going on. Now, I have the answers in my sight. Go ahead and trace and figure out and you can see it's moving, but not very much. It's not going very fast. Use it around a little bit. Trace faster. There it goes. Now, I have one solution that could be 1.98 and 3.94, but I'm going to go ahead and guess. Let's look. That's an easy way to get it. Here is where both of them have the same y. X is 2, and they both have the same y. That is going to be one solution. 2, 4. Since the graph wouldn't show us, 2, 4 is one solution. Now we have to find another solution. Well, we know it's going to be bigger than 2. Where do they both have another solution? Now what I did is I went up here and I changed my initial 0. Or my initial x value to 0. Now what I can do is I can keep scrolling. I'm going to see where they both have the same value again. Where do you see that the y values are once again the same? It was right in front of me and I couldn't see it. Right here. At 1, 1. So my two solutions are 1, 1 and 2, 4. How did I get this answer? I'm going to go through this again. I put my equations inside my calculator. I told it to graph it, and it did. I can see it hits 2 times. So I went to my table and I used this to figure out where are my y values, my x and y values the same for both equations. They're both the same when x equals 1, the first equation equals 1, and the second equation equals 1. They are both the same when x equals 2, the first equation equals 4, the second equation equals 4. That's how I know where my two solutions are. So we're going to go back over to our answer, and we're going to put in 1, 1, and 2, 4. Question 9. An analyst researches the relationship between different energy sources in each state for 2014. The data in the table shows the number of states that use coal and nuclear power as an energy source. Given that a state does not use nuclear power, what percentage of those states use coal? Now, in order to do this problem, we have to know how to read this chart, okay? It asks, given a state does not use nuclear power. So here's the states that use nuclear power up here. Yes, they use nuclear power? No. So we're saying given a state does not use nuclear power, what percentage of those states use coal? Well, to find percentage is a part of a whole. So what part of the whole? So we're going to say 20 out of how many states do not use nuclear power? 20 plus 12. So it's going to be 20 divided by the total 20 plus 12. So it's 20 divided by 32. We're going to go over to our calculator and we're going to put in 20. Now, in order to get it back to the calculator, just click on scientific. 20 divided by 32, 62.5%. How did I get 62.5? Well, 0.625 as a percent, we just move the decimal point twice to the right. So I'm going to get 62.5%. Part of a whole. What percentage use coal? 20 out of a total of 32. 20 use coal that do not use nuclear out of 32 that don't use nuclear. A group of students measures the distance a toy car has traveled for different amounts of time. A table of the data is shown. The students want to perform an analysis of the data set and consider removing the outlier point. Select all of the quantities that will change if the outlier point is removed from the data set. Well, we have to know how to calculate all these in order to get the answer. What is the mean? If we remove the outlier, will the mean change? of the time. The average time. Is the average time going to change if we remove the outlier? No. What about the mean of the distance if we remove this outlier? The outlier is this guy right here. If we remove the outlier, will that one change? Yes. So the mean, the average of the distance will change. What about the median of time? Is the middle time going to change? No. What about the median of the distance, or the middle distance? Is that going to change? No. The range? Well, if we remove the outlier, the range of the time will not change. It's still from 5 to 15 seconds, but the range is 1 to 11 if there's an outlier. If we change the range is 1 to 4.9. If we remove this, the highest number is 4.9.